Okay, everyone. Happy April. It's 4 o'clock now, so we're going to be in the class. We're going to continue with dynamic programming. Today's going to be our last lecture on dynamic programming, actually. And then our next project is going to be a dynamic programming based one. And the exam is going to be very heavily dynamic programming. I'll tell you that up front. It's an important topic. Make sure that you understand this. Yeah, question?
Is this next project our last one or our second to last?
We'll see. I'm still deciding.
I decide how to weight my late day.
So I will say that's a good point. That's a good point. Well, you'll have an answer to that question, I think, shortly, probably. You can ask me after class if not. But yeah. So I do intend, as I was saying here before, I intend to make this class slightly more top heavy, where the beginning of the class is a bit heavier, and that will somewhat end with dynamic programming. That's not to say the class gets easy past this point per se, but I do want to wind down the amount of work that I'm giving you if possible. So I'm probably only going to give one more project, but we'll see. The projects are fun. I'll probably give a bonus project that will override whatever your worst project is, or something like that. We'll see. I'm still deciding that. I reserve the right to make changes as I go. Okay. Furthermore, this is a very important topic, as I've said.
I got free cookies from the career fair. Can I just leave them here? I'm gonna leave them here, guys. You can.
No, you have to ask questions to get cookies.
That's insane.
And then if there's any left, then I'll eat them all. What? Okay. But because this class, yes.
Could you please remind me what the late day policy is again?
So late day policy, you have 5 late days. You can use them on whatever you want, on any assignments. I leave the late day open on Gradescope, but we're going to go through and make sure that you only use 5 total, or else you're going to get a hit to your grade. Just don't do that, because I'll have to decide on a policy for how much to deduct your grade. Yeah, so furthermore with this, this is a very important topic. If you struggle, I'm going to just power through for right now. If you struggle with this at all, what we're going to do today, we're going to do 2 practice problems, basically, and I'm going to go through them with you, see how to solve them, give you a chance to try at them. And if these are giving you a lot of trouble, then go to office hours or the SI session. I believe Tomas said, yeah?
I'm guessing because the homework is currently due today, right?
Yeah, it's due today.
But because of that, I think not many people came to the first one. I spent like 3 hours in the makerspace making the board though, so I want to get use out of it. And I think it's a fun activity, so I'll be doing it again on Thursday if anyone wants to go to that.
Okay. All right, go to that. It sounds like it's going to be a useful bit of practice. There's only so many hours that the rest of us can do office hours, so make use of your resources.
Oh, it's in case you weren't here on Monday, it's we're gonna do another Pebble game, but it's more complex.
Yeah, we're gonna do a dynamic programming problem. Good practice and all that. Cool. All right. One more bit of administrative thing. Gotten quite a few requests to extend the project to deadline. Only have 60% submissions so far. Just kidding, it's only 20%. So I am willing to consider it. But this is in tandem with me also offering the midterm reweighting, where I take the max and that one gets more heavily weighted. So I'm gonna let you all vote right now which one of those 2 you'd prefer. Okay? So either. So let me explain. Option A is going to be that I'm going to weight your max exam twice as much as your worst of the 2 midterms. Yeah. Oh, no, not yet. And option B is going to be an extra week on project 2. Okay, so raise your hand. Yeah, question. A week is a lot. Yeah, other question in the back. I cannot hear you at all. Yeah. That's exactly just raise your hands. This is at least going to inform me how people feel about it. You can raise it for both if you want to, but that will just make it, that's like not voting. So, okay, so if you'd like option A, that's the exam thing, raise your hand. Okay, if you'd like option B, the extra time on the homework, raise your hand. Okay, okay. I'll give you both. I'll give you both. Anyone want any cookies? You can't have. Okay. Okay. There. Enjoy your April Fool's present. It is real. It is real. I'll extend the deadline. That's fine. That's fine. And I think the midterm thing makes sense for me. I want people to be able to make up for midterm 1. It will probably, midterm 2 will probably be functionally more difficult, just for the record. So if you want to increase your grade, study up on dynamic programming. Okay? Cool, cool, cool. Any questions? Any questions? Anything else? Anyone have any more snacks or demands? No? Okay, cool. So, we're going to start with a problem here. So first up, just very broad review of dynamic programming. If you've missed the previous classes on dynamic programming, watch the recordings. You need to know dynamic programming, and I'm not going to fully review it today. We're going to do a couple problems, but we're not going to go through the full thing again. But the basic idea of dynamic programming is we saw that in some problems, if I approach it in even a not naive, but in a non-optimal way, then I can repeat the same computation lots of times. It turns out that I end up with the same sub-problem multiple times, and it turns out by doing that, I can get exponentially bad runtimes. I can repeat a ton of computation. So Fibonacci numbers, we can get 2 to the n to calculate the nth Fibonacci number. That's insanely bad, because in reality, we can get log n. We can go way, 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 way better, just by not repeating computation and being a bit clever. So the fundamental idea of dynamic programming is we want some clever way, some set way that we are going to store the work that we've done previously. This was called memoization. Still a stupid term. Memoization is when we memorize sort of all the work that we do, and we can use that. And then a dynamic programming array, which is what we're doing here, is sort of a systematic way to store things, generally in an array. In fact, in dynamic programming, we will consider them all to be able to be done with an array. There's a bit of theory there that we're not going to talk about. Any questions on that? Okay. Well, we're going to start with the first question of the day, which is, given a sequence of numbers, let's say integers, just make our lives easy. Let's say we have 1, 3, 2, 5, 8, 4, whatever it is. I want to take my list here, and they can be negative, by the way. They can be negative, they can be 0, whatever. I want to find a subsequence that is in order, that is monotonically increasing. So what this means is I want some subsequence, let's say, for example, 3, 5, 8, such that if we go in order from left to right, they are exclusively increasing. Okay? And what I'd like to do is I'd like to find that sort of subset out of my array that is maximally long. So in this example, what is the maximum length monotonic subarray? Yeah.
By long, do you mean the number of elements?
Number of elements, not the sum.
Okay.
Exactly. So if we add the 1 on here, then it would be 4 long. 1, 3, 5, 8. Okay? So, yeah.
There could be more than one, right?
There can be more than one that are equal length. 1, 2, 5, 8, for example, here, would also be 4 long. You just need to return one of them. Okay? Yes?
So, like, there just can't be that break.
There can be a break in between the terms. We just need, so I need basically, you could think I'm returning a list of indices, like 0, 1, in this case, 0, 1, 3, 4, so that it's always, like, they're in order, and also each one of these elements gets larger. So the 1, then 3, then 5, then 8 are monotonically increasing. Monotonic means only increasing as I increase, like, a monotonic function is as I increase x, then y increases. So a larger x means a larger y. Yes?
So if you found,
Yeah.
if you found those, would you just
Up to you. As long as you return one that is maximal length, that's fine. Okay? So I'm going to let you guys attempt this problem. This is sort of like the warm-up problem of the day. If you have a lot of trouble with this problem, or seeing how this is a dynamic programming problem, then that means that you need some review. If you can't come up with something in like 5 minutes, then that means that you need some review on dynamic programming for sure. Okay? All right, I'm going to give you a couple minutes. One thing I actually want to ask first, though, this is whenever we get a problem like this, it's a safe bet that we should do this. How long would it take if I do this naively? If I try to do this, what could it look like? What would the runtime be? N squared. Not quite, because it's not a start and end point, right? So the n squared would come from the idea, like with the maximum subarray, what we did is we had a start and an end, and it's every possible combination of those is n squared possible options. Here, we're allowed for holes in the middle. So it actually increases the number of things that we need to count. Yeah? It'd be 2 to the n. 2 to the n. Basically, you can, for that argument, I can say each one of these is either in or not in my subsequence. So each one has 2 possible options, and each one of those would be one valid subset for me. Obviously, some of them are going to be vacuously untrue. That is, all of them not in my list. Obviously, won't ever be the case. But we do have 2 to the n. So naively, this would be 2 to the n. So that is going to be something that we will need to beat with our algorithm. But generally, in these sorts of problems, like an n-long array, you should expect it should be some polynomial event. Is usually a safe bet. So naively, we could get 2 to the n, and I'll let you all attempt it now. Take about 5 minutes or so. I'm also going to let you talk to your partners. If you want a hint, or if you don't understand any of the question, raise your hand. I'll come by and help you out. Okay? No. First, work alone, by the way. The first, use as a test to see where you're at personally. If you feel very, very good about this problem, then maybe work on your homework for a little bit. But beyond that, if you can't figure out how this is dynamic programming, that's just an indicator that you need some more practice. Okay. 5 whole minutes. as long as it would always find it.
Okay, because it would like only find one person.
Okay, I'm going to call that as 5 minutes. So at this point, if you don't have a notion of how this is dynamic programming, then I'd say that it means that you're behind in terms of understanding dynamic programming. Just so you know. So that would be study up a little bit. If you got closer, you understand some things in the problem, obviously you can be close to, I think, prepared for it, but just, this is pretty close to like an exam question I might give you something like 30 minutes on to do this and then prove correctness, something like that. So if it's looking difficult, this is about the difficulty that you should expect on the exam. Okay. So now I'm going to open it up so we're going to talk for a second. First, I want to hear if anyone has any ideas about this. Yeah.
We take the list and at each index
Okay. Okay. So you're saying that we want to store some array. Again, we will call it opt. When we're doing optimization problems, generally we just call it opt. You're storing somehow in this array maximum values, right? I'm going to leave this as a hint. By the way, I'm not going to press you more on your algorithm because there is something here. You're saying you want to store values in here, which are let's just say here, which is the max monotonic subarray value. Ending at this point is what you said, right?
no, the length of the max.
The length of that.
Yeah.
So this would be of length 1.
Yeah.
Right? And then you continue through. Okay? So the basic idea of dynamic programming, as we said before, you're going to want to store something. And so this is some notion of something you might store. I will give you all the additional hint that this is not the thing that I chose to store, and I couldn't tell you if this is fast enough to calculate off the top of my head. But it is the right size of the thing that I would store. Okay, so that'll be everyone's hint. Is that you just need a 1D, you just need an array. You don't need something more complicated than that for this problem. And now I'm going to open it up for all of you to work with people, again, about 5 minutes. I want to save more time for the harder problems so you guys can sink your teeth into something. Okay, go ahead.
I'm hiding mine.
Oh, you're hiding.
Yeah. I didn't think. I think it would work. I think it would work. Probably better because I just go through set of the variable to like the most. Obviously, you start with everything by itself, and then you set the mean to one, and it's like the most recent one that will be one. But I think this is not right. This is still my kind of
So then you get 2 by 2 now.
Okay, but mine. Okay, I think it works. I think it works. It's a lot bigger than what Cinnamon did. But like, but it works in my opinion. I think it works. But it either works or doesn't. I think it works. It works. But if like on an exam, you got a solution that was like faster, but I still did dynamic programming and just figured like.
I think, you know, most things I don't do so well. I like to do so, question for you: how long does it take you to
Like, is it comparing variable? Okay, because I have a variable, and I set it to the last Boolean one. Everything starts at 1 on itself, obviously. And then if it's bigger than what my variable is, it gets a 1, and then the variable updates to that. And then it changes. So just like turn this like here, like you go next.
yes, I can do it.
The longest one. The one with the most ones in it, the row with the most ones. Yeah. Yeah.
So this figure, I'll have this here that stores that the element is larger than 0.
And first, yes.
Yeah, first. So that's being everything. So to be constructing this, constructing all this is not necessarily because this one is this one has to compare to
Not everyone just goes through someone, because if this is bigger than this, obviously if this is bigger than that, it's bigger than that, so I don't even care. Wait, what is it?
Oh, my goal is this. This is one. If you score this is the biggest one and you look back, you can't attach any. So you think, oh, I think someone's so really you can make one.
Backwards.
Well, there's some mathematical the maximum for everything is usable. So this would be it so that if we have like given max, let's say this was 5. Like let's imagine this is 5. That's not
Okay. We have a second hint now. I will say now is approximately the time that you should start figuring out a solution to this problem by our pacing. The first check-in was basically you should realize how you might do dynamic programming, like you want a 1D array, for example, stuff like that. Now you should have some, at least first approach that you can see if it's true or not, and you should be able to check. You can check against this. There are multiple solutions to this one. I know that there are multiple solutions, but I'm going to tell you what I store in my array, and that does work. Okay, and then you'll have to figure out how to make it work. Okay, what I store in each one of these is going to be the and this is assuming we're just returning the length of the subarray. Otherwise, we just have to do other bookkeeping. So I'm just going to keep it like that. In each one of these, I'm going to return the max length of a monotonic subarray, ending in this element. Ending. With the corresponding element. So, for example, sorry, there's lots of type, lot to write. So, for example, in this first one, it says, what is a maximum monotonic subarray that ends in this 1? What is it? 1. It's 1. Okay. How about this one? It'd be 2, 1 and 3. Anyway, that's how I fill in my dynamic programming table. Give it a go. Oh, your question first. Oven. You can get Oven. Yeah. All right, continue. Yeah.
That's my question. Can I have a cookie?
I will give the cookies in this one.
Well, that experience like sticks to me.
There's probably some it takes me Hey, real quick, someone caught this. It's n squared, not over n. Sorry. Yeah. You can probably, by the way, for you guys, probably do n log n. I think you can. I think you can do n log n if you're very clever, but n squared is what you should aim for. Yeah.
I think that solution given earlier would be n squared.
This is n squared.
Yeah.
That's what I just said.
Oh yeah. And then,
Yeah, I can't imagine. Just gotta get that correct
I have a fucking I'll tap it. No, we have 2 weeks. I don't know. I might. No, it's okay. It's like the woman is so she's super sweet and normal, but she's so weird. She talks all the time.
Do you have the bonus from last week? Binary array. If you're done with this one, start again.
But you like know what I'm talking about. Pretty awkward. Yeah, I don't think it's very this one's pretty bad. I don't know why it's
That's great. I think we're gonna need some sort of because we're doing so we're proving that we have an optimal subproblem, and that could be separate. The number of possible options in your algorithm is a set of the ones that you use. There are like multiple ways to say the same thing fast. All right, cool. Hello, everyone. Hello. So first up, I want to ask. Try not to be embarrassed about this. Who was not able to get a solution? Anyone willing to share? Raise your hand. Raise them proud. Yeah. Okay. Those of you who raise your hand, you get a cookie for being brave. Yeah. None of the rest of you. Okay. Anyone willing to share their answer? Share how they did this problem. Yeah.
Yeah. So starting from left to right, basically, or max like substring.
Good card.
So it's easy for the first one. And then like if you moved on to 3, then basically you're gonna check every value. Say if this value is greater than that one, then we know it's at least gonna be.
So this is exactly it. Is as we check these, we see out of all of the ones previously that we are larger than, we can take the maximum of all of those and then add 1 to it. So if I say there's some sequence, let's imagine we have other things ahead of this, that ends in 1 of some length, then I know when I go to this 2 that I could say that the maximum sublength is all of this, and then I appended 2 on top of it at the end of it, and that would be my new maximum monotonic subarray that ends at 2. Right? So it could be this, whatever this value is, plus 1. But for this one, because it's smaller than this, obviously it can't be appended onto that one. And it turns out that by doing this, we are capturing every possibility. So in fact, we can fill it in. So this one would be 2 because it is after that. Then for 5, we have to check all of the options that it is larger than. All of the things previously that it's larger than. So it's larger than 2, it's larger than 3, it's larger than 1. So we look at all of these, and then we are going to take the maximum of those and then add 1. So functionally what we're doing is we're looking at the subsequence that ends in 3, the longest one that ends in 3, we have the longest one that ends in 2, and we're saying and the longest one that ends in 1. We're saying which of those is the longest, and because 5 is larger than any of these, then I have any of the options. I can take the largest one of those and then append 5 onto it, and that will give me a new monotonic subarray. Yeah. So we will need to know like all these comparisons. This is where I was saying that there could be a slight speed up where we get n log n, is by doing that cleverly, say storing that in a binary search tree or something like that. I'm not sure entirely if we'd actually get the n log n speed up. I'm not gonna work it out right now, but perhaps. But in short, we still need all of these comparisons. We still need a comparison of this to everything before it and all of that. But there may be some clever way that we could organize our memory. Nothing comes to mind immediately for me though, so it's possible that there isn't. Yeah?
Can you use a heap?
Yeah. So that's exactly what I was getting at. Is possibly that would give you a save on the runtime, but you'd have to construct it ahead of time, which is only n log n, right? So you construct it ahead of time, possibly. So possibly you could end up getting n log n for this problem, but I'm not going to worry about that optimization at this stage in the class. Yeah.
When you're actually output or whatever, are you just values for that using
Yeah, so anytime we compute this, we just need to look at the things that it's larger than. If there's something that's larger than it earlier in the array, then we know that it's not going to be appended onto that subsequence. All right. And are you asking about how do we return the actual subsequence?
Yeah.
So that's just bookkeeping, honestly. So for each one of these, we can include a tuple also, or some list that is all of the elements. So like this one could be 1, 3. This one would be like 1, 2, and then this would be perhaps the first one that we see 1, 3, 5. We can also include this in memory. This would give this a slightly worse runtime, but we also can do this somewhat cleverly too. So don't worry about that too much, because these are repeated. So we don't actually need to necessarily, like as soon as we do one of these, we can drop these. We don't need to remember them anymore. So at worst, it's going to be n more memory. But anyway. Cool. Yeah. Anytime we have a problem where we're returning some optimal value like this, like the length of the array, it's generally as easy and as memory intensive to return the solution itself. That is what the maximum subarray is in this case. They're generally like equivalent problems. We're actually perhaps later on going to show that they're equivalent if we get to that in the reduction section. So don't worry about it particularly. As long as you're returning this value, you've done the hard part of the problem. And doing the rest of this is basically just bookkeeping, a little bit of programming knowledge. Okay? Okay. So now, any questions on this before we move on? Okay. Well, I gotta grab the quiz from my bag. Just kidding, it's candy. Yeah. I'm kidding you guys today. So candy's on the table now, along with the cookies. You kind of upstaged me a little bit. Anyone who asks any questions for the rest of the class, or previously in the class, can take one of these, okay? Not the bag, that's something inside. Okay, cool. No quiz today. If you want to leave, you're welcome to leave now, I guess. No quiz today. We flip the coin, who's tails. I do actually still flip the coin. I'm not kidding about that. Okay. So now a slightly harder problem. I know some of you have done the bonus already, and this is the same as the bonus problem. I can maybe talk to you about some different problems in the meantime for you to work on if you've already done the bonus. But for those of you who haven't, this is a little bit more of a this would be the upper bound on what I would possibly test you on in this class, in terms of dynamic programming problems. Certainly there are harder dynamic programming problems, but this is going to be about as hard as I'm going to ask of you in the class, in fact, in this class. And I want you to really try to get the answer to this. These two problems are in some way connected, by the way. That's your hint for this problem, but let me explain what it is. So, problem fairly easy for me to state is just given a binary array, that is an array, or a matrix, sorry, a 2D matrix, an n by n matrix of all zeros or ones, so it's entirely made up of zeros or ones, something like this. Let's just come up with an example. Something like this. So it'll be n by n, in this case n is 5. It's n by n, and it has ones and zeros making up all the elements in it. Something like that. Okay? Your job is to find the largest area rectangle, so the largest rectangle in here by area, of all ones. Okay? You have to be able to do this. I'll give you a runtime for this. So naively, let's do naive first. Naively, how bad is this? That's a new problem for the bonus crew too. Yeah? What do you think? N cubed? Yes. That is slightly less naive. It depends what you consider naive for this problem. Let's say if I want to check every possible rectangle. So if I check every possible rectangle, calculate that area of that rectangle, and then compare them all together, how long would that take? Yeah? N to the n? I don't think it would. That's fine. Don't. But n to the n, by the way, just a small thing. N to the n is roughly n factorial. Just a fun fact for you all. But you can uniquely identify a rectangle based on its upper left and bottom right location. So we just need to do every possible pair of choices here. So we can consider that n squared choose 2, which is just is going to be order n squared squared, or n to the 4th. Would be the naive thing that I would say is most initially naive. Yeah.
We also have to check if they're filled with 1, so it'd be like n to the 6.
True. We have to check the area of each one of them, which is going to be n squared for each one of them. So sure, let's say n to the 6. This would be very, very naive to do. Doing this full thing as n to the 6. Let's say it's something like that. Yeah. No, because each one of the choices we have to check for ones. That's if we're being extremely naive. This would be a very, very stupid algorithm, and it would be n to the 6, and it would be horribly inefficient in the real world. So naive would be something like ON6. What we're aiming for, and the only acceptable solution here, is going to be, I guess, one of the bonus guys. What do you get into runtime? Yeah? What do you get? Runtime.
Oh, n squared.
N squared, that's correct. So in this, we can get n squared. Okay? So I'm going to leave you to consider. Again, I'm going to give you the first. Let's say this is like 5 or so minutes. Is a little light on the time to consider this, but come up with some idea of what your dynamic programming array is in about that time. Okay? And this is work alone. Just again, this is a test for yourself. This is a slightly harder dynamic programming problem. It's not tremendously harder, but it is harder. And I want you to think about it. Okay? Go. Yeah. The solution that I have is
I don't know, I haven't created these yet. Like, I know I'm like, basically, I just keep track. Find greatest height in all of
that.
and then it's a whole thing. I wrote a proof. There's a short proof. It's a lot of words.
I can agree later.
It helps that I've seen it before.
So no that. Yeah, it has to be continued.
No, I had attempted it.
Yeah, we'll
So I saw some way. And it was like,
start the end also. And it may be the project that I'm dropping.
how am I supposed to figure out a whole homework?
I haven't even figured out this thing.
Yeah, my main point is
How do you know how they match up?
it doesn't matter. I mean, it does matter, but like first point is that they can find a column of ones. So like in this
Go ahead. If you want to grab your cookie or candy now, you can. But only if you ask a question.
What's in the candy?
It's the same one as before. Kit Kat, Almond Joy, Reese's, yours. Yeah, it's fine. It's fine. Yeah, this one probably won't do a lot.
No, I saw them in discussion like I knew for an hour, so I didn't do it.
Oh, yeah. Oh, yeah?
That's what I was thinking.
What's that? Give you the. We have to be a little bit more clever than just that, but.
That was like
Or I guess you could technically sound like a school. That's if it's a scene from top to bottom, I feel like.
you just need the width and the height.
The solution's clean. There's no way this is what it's described as.
Yeah. There is a
For any given corner.
Did you sit down and like, okay, explain this? Look through this here. This line is so perfect. There's an artistry to like explain this. Like you'll see I'll explain this from but and there's like a, oh, that's and then pseudo you're being more formal. That's fine. It's
I'm afraid of the ollie.
There's nothing wrong with it. This is what you have to do right after research paper, or if you're actually like the max using someone, but there is, you know, if that's what you're aiming for, then good practice. If you're aiming for software engineering or whatever, this is more than
so you know that
I'm not thinking. There's a little bit of artistry left to learn.
What if I just duplicated row 2?
what was for M by N?
I suppose being able to be concise.
Oh, that's why.
Here's my storage, and here's what is stored.
You know, if you
I have an unlocked array. It's just where your element is an important part of the chain. Enough so that just like the whole it's going to be
like I would just read all the way across.
So stuff like it's not like these things. I'm not thinking of solutions. That's what I'm saying, like, if you want to do like serious algorithms work, this is so you can be able to I think the best way to practice it is explaining. What are the things
I'll do my rubber duck. That'll make it easier for me to get 100%.
I just want you to give this. I'm going to talk about it later. Okay, so hint number one. Also, who was able to come up with a dynamic programming array, like what they're storing and all of that they think would work? Okay. Sure. Okay. What's the size of your storage? N squared. So this is exactly what I would expect. This is if we're going to getting a runtime of n squared. then probably we're going to, we need something that is smaller than or equal to n squared. If we had an n cubed thing, then even if we took constant time to fill in every element, then we'll end up taking too long. It'll be n cubed. So we're going to restrict ourselves to that. There's a chance that we could fill in just some portion of those of the n cubed storage, but then we're being a little bit silly. Anyway, so we're going to have our octarray is going to be n by n also. And very similar to the last one, each element here, we are going to want to correspond to some property of one of these elements in our original array. Okay? That's going to be the initial hint. With that, I'm also, any questions on this at this point? Okay. I'm going to allow you now to talk to your neighbors and all that and be a little bit louder. I'm going to give another bigger hint. I'm going to tell you what to fill in with this array in about 5-10 minutes, but try your best to get it before that. And it will, if you do, you'll feel a lot more clever. Okay? Ready? Go.
From the biggest rectangle including the right? I guess we're just I like when trying to phone this, right? This is two commas and like oh we also throw like four commas here. This guy's not but the biggest space, so you can like, oh, we're left to do this on its own.
So when you're trying to decide what this is, you need to look at this one. I'll show you.
I'm 2D arrays and every single a 2D array and at every single one it's like, oh, here's 0.00 at every single point. And then it's like you store all the points of all like the large checks that you make. It was
It's a fun one to make. It's a good project. You have to expand it. This was my first idea.
But first you have to each and then you also have to each column because it's really long. If you're keeping track of the losses, you're never going to get that one. You're getting that one. I'm saying, I'm telling you, there's going to be a piece where it's like, yeah, check off. I've gotten like 5 things online.
All right, hint 2 time. Hint 2 time. Here is what I store in my 2D array. For every element here, I say that this should be the length and the height of the largest rectangle where this, of all ones, where this is the bottom rightmost element. So for example, this one would just be 1, 1, right? But eventually this one here would be, for example, this would be only length 1. I did it length height, I guess it's fine. It'd be length 1, height 2, because it has a 2 long right there, where it's the bottom right. Okay, does that make sense? All right, so this is going to be the array. I'm going to give you, I think, another 5 minutes or so, and then I'm going to go through the answer quickly. I want you to give it a good go, okay? Go.
I like yours better than mine in it.
Well, what would these ones be?
Yeah.
You said this too.
I did. Everyone should try one out.
I feel like that's
Well, if you have ADHD, it makes you like normal, and it quiets your brain. And then if you're normal, you don't use it. It's not. It's a molecule of that actually. Thank you. It's not quite.
Every single n squared time. You don't need to do that. Okay, that was like my idea. This is a no. Solid block.
My friends look at her on the party, and she's like, damn, so like how she has
the second one.
she just have to take either.
That scores.
For the solution that I have. One is very different than one.
But like, I just got like 11.
You want to be able to see
Yeah, this one is.
Well, no, I have it, and I see myself down there, and so, you know, you would also for this, you also
Percent, that's bullshit. I feel like everybody.
it's like 0.2%. Although they do
But then possible.
maybe this pressure this is what I try to remember just in thought why I do this.
Everybody knows. So this one, yes.
Well, it's funny.
So when you really see them, they really have to look at so you're only ever looking at west and north.
Why is you would be concerned about
Oh, yeah, so down.
and I just don't want
I thought I was going to see tight.
No.
you don't.
You don't.
Yeah.
That's my picture to make it.
My grandma after this, so like I'm not.
Describe exactly.
What if it's part of two equally sized rectangles?
Are you doing any?
I just arbitrarily pick one.
Making the actual rules, actually.
Yeah, that's what
I give it up, so I think right now,
Wait.
you did.
We can have like
yeah, so maybe we two things that, we might too.
the one by three or two by one that intersect.
You just have to remember to add one.
Fill in the black one there. It's gonna be 2 by 2. You can get that from those.
Oh, yeah.
What if there's a 2 by 2 is not like. Did we talk about iteration instead of like iterating instead of memorization?
We gave it. I'm not gonna name that.
Yeah.
I think they honestly.
I know what it is. That's fair.
Okay. So I'm gonna give you a sketch of the solution now, just because we're almost out of time. If you want to hear it more deeply, or if you actually just want to talk review or anything like that, I'm probably gonna stay after quite a while today because I need to stay on campus until 6:30, so I'll be hanging around. Anyway, the major insight that we can see is that given the height and the length of a cell to the left and above any given cell that we want to fill in, we are able to tell what the value of this cell should be. So this is a little pictogram for you to show this. So if I have, this is the rectangle, which has the bottom right corner being this above cell, and this is the one to the left. I've labeled them above, or upper and left. And I look at them, and I can tell just visually that the largest array, the largest rectangle for this one, is going to be the intersection of these two. So it's going to be the intersection of these two. It's going to be this one right here, right? It's going to be like that. Okay, so we can see that visually, right? But what would that mean if I have these two values? What would this end up being? Anyone know? So just look at it visually. Think about it for a second. So what am I actually doing? So this one has some height. This one has some height. Then this one has some length. This one has some length. What is this right here? What are the width and height of that? Yeah. almost just the minimum. So it's not quite just the minimum of the two. So what's suggested here is that this should take the min, so its length should be min of the length of each of them, the length of L and the length of U. Is that quite right? Why not? Yeah.
What if there's like all
So that's true, that's true. So if they're all zeros, then this would end up being 0 when it should be 1. So that's an edge case for us that we have to deal with. Perhaps though we could just use an edge case for that. We can just have a specific case for that. So maybe not a huge issue. Yeah? Exactly. We need to add 1 to the L length. Okay? So because this one is going to be 1 longer, essentially, because I'm adding 1 to the length if I take the length of this one. Right? That makes sense? Where this length does not add this one to the length, this one would. Right? So it's going to be the L length plus 1, and then it's going to be the then it's going to be LU. And similarly for height, so there's going to be the length of it, and the height, very similarly, we do the same thing except reversed. So it's going to be the minimum of the height of L and the height of U plus 1. Okay? And now there's multiple ways that we can rephrase this to handle this edge case. Maybe you guys can consider that. That's not the most important thing to notice about this, though. If this is the thing that I can do, so given the left and the top thing for any one of these cells, how can I fill this in? How can I actually get my answer? What order could I fill them in where I only ever fill in something if I have the top above it and to the left of it? Yeah.
Starting from the top left corner.
Start in the top left corner, and then what would be the next one?
The next one from there would be go to the right.
Okay, so I could go to the right.